Hi, in this video, I will be showing you problem number 5 of chapter 9 section 1. Which of the following functions are solutions of the differential equation y double prime plus y equal to 5 times sin x? A. Y equal to 5 sin x. B. Y equal to 5 cosine x. C. Y equal to 5 halves x sin x. D. Y equal to negative 5 halves x cosine x. So let's try now one by one whether any one of these satisfies the given differential equation. We will call the given differential equation as equation 1. So we'll first try the A, which is y equal to 5 sin x. The equation involves y double prime, so we have to get y prime and then y double prime. Y prime is 5 cosine x, y double prime is negative 5 sin x. So if we substitute if we consider the left hand side of equation 1, which is y double prime plus y, this will be equal to negative 5 sin x plus y, which is 5 sin x. That gives us 0. So it's not equal to the right hand side of the given equation, which is 5 times sin x. So on the right hand side of 1, you see here 5 times sin x. See 5 times sin x. So that is not the right hand side. So A, 5 sin x is not the solution. Now let's try B. B is y equal to 5 cosine x. We try the same thing, y prime, which is negative 5 sin x, y double prime, which is negative 5 cosine x. So if we find out the left hand side, y double prime plus y, which is negative 5 cosine x minus 5 plus 5 cosine x, that is 0. So it is not equal to the right hand side. The right hand side is 5 sin x. So B, so your conclusion is y equal to 5 times cosine x is not a solution either. Let's try C, which is y equal to 5 by 2 x times sin x. So y prime would be, so now we are going to apply the product rule. So 5 by 2 times x times cosine x plus sin x times 1. Now if we do y double prime, it is 5 halves. We have to do the derivative one more time here. So here you have to apply product rule. So x times negative sin x plus cosine x times 1. So that completes the derivative of the first part. The second part is derivative of sin x, which is cosine x. So it is 5 halves negative x sin x plus 2 cosine x. So if you consider the left hand side of equation 1, which is y double prime plus y. So y double prime, if you distribute it, is 5 halves x sin x, then it will be just 5 cosine x. If you distribute, the 2 will cancel out. Plus y is the given function, which is 5 halves x sin x. So these 2 cancel out, but it results in 5 cosine x. Still it is not equal to the right hand side of the given equation, which is 5 sin x. So again you conclude that 5 halves x sin x is not a solution for the given equation. So we are left with only the last equation. Probably it works, we will find out. So part D is negative 5 halves y equal to negative 5 halves x times cosine x. To find out y prime is the derivative negative 5 halves x times negative sine x plus cosine x times 1. So that will be negative 5 halves negative x sine x plus cosine x. That is the first derivative. Then we will find out the second derivative. That will be y double prime, that is negative 5 halves negative x times derivative of sine x, which is cosine x, plus sine x times derivative of negative x, which is negative 1, then plus derivative of cosine x, which is negative sine x. So if you distribute, it will become 5 halves x cosine x, and then negative sine x, that will add up to negative 2 sine x. So it will be, when you distribute, it will become plus 5 sine x. So now if we do y double prime plus y, which is the left hand side of the equation, so that will be 5 halves x cosine x plus 5 sine x from the step, then plus y, which is negative 5 halves x cosine x. These two cancel out, leaving you with 5 times sine x, which is exactly the right hand side of the given equation. So our conclusion is that therefore y equal to negative 5 halves x cosine x is a solution to the given differential equation. Hope this video